Hi, here we have a and b are integers such that 2x square minus ax plus 2 is always greater than 0 and x square minus bx plus 8 is greater than or equal to 0 for all real numbers x. Then the largest possible value of 2a minus 6b is what? So we have to figure out the largest possible value of 2a minus 6b. Now to maximize this, we need to maximize a, right? And minimize b. Since b is getting subtracted, we have to minimize b. So we have to calculate the maximum possible value of a and the minimum possible value of b. So let's start from this equation. Now this is a quadratic which is always greater than 0 and the coefficient of x square is positive. Since coefficient of x square is positive, this will be an upward facing parabola, and since it is always greater than 0, the parabola will lie completely above the x-axis. Since it lies completely above the x-axis, it means there are no roots of this equation. There are no real roots of this equation. The graph does not cut the x-axis, hence there are no real roots, and the condition for no real roots is that d, the discriminant, should be less than 0. So if the discriminant is less than 0, it means b square minus 4ac is less than 0. So b is the coefficient of x, which is minus a, so minus a whole square minus 4 times the coefficient of x square, which is 2, into the constant term 2. This is less than 0. So we have a square is less than 4 into 2 8, 8 into 2 16, minus 16 goes that side, becomes plus 16. So a square is less than 16, hence a will be less than 4 but greater than minus 4. A will be in this range. So what is the highest possible value of a? The highest possible, since a has to be an integer which is less than 4. So the highest integral value of a possible will be 3. So the maximum value of a is 3. Next, let's focus on the other equation. Now this equation is greater than or equal to 4. So, and the coefficient of x square is 1, which is positive. Since the x square coefficient is positive, the graph will be an upward facing parabola and it is greater than or equal to 0. So basically what will happen is the graph will touch x-axis and go up. So that means this graph or this quadratic has real and equal roots. Now what is the condition for real and equal roots? The condition is that d should be equal to 0. Or it is also possible that it lies completely above. It can be either greater than 0 or equal to 0 as well. So it is possible that the graph lies completely above. In that case, d should be less than 0. So let's combine this. We say that d is less than or equal to 0. This is what we have. So now the discriminant here will be minus b whole square minus 4 times of coefficient of x square into the constant term. This should be less than equal to 0. So b square is less than equal to 4 into 1 into 8 is 32. Minus 32 goes that side, becomes plus 32. So b square is less than or equal to 32. That means b is less than or equal to square root of 32 but greater than or equal to minus square root of 32. Okay. So now 32, square root of 32 will be approximately how much? 5 square is 25, 6 square is 36. So this will be 5 point something. So this is minus 5 point, let's say x, which is less than equal to b, which is less than equal to 5 plus 5 point x. Now since we need to figure out the minimum possible value of b and b is also an integer, the least possible integer b based on this inequality is minus 5. So the least possible value of b is minus 5. Hence, the maximum possible value of this expression is twice of a, which is 3, minus 6 times of b, which is minus 5. So we have 6 and this is plus 30. 6 plus 30 is equal to 36. So the maximum value of this expression is 36. Thank you.